Hello and welcome to the video lecture on the proof of convolution property in Fourier series. So let us first see the statement and the proof for convolution theorem in Fourier series. So according to the statement, it states that if z of t is equal to x of t convolved with y of t, then its Fourier series representation is given by z of k is equal to capital T into x of k into y of k. So this is what is a statement of this convolution. Now let's go with the proof of the same. So first we will start with the definition of Fourier series. So z of k will be given by 1 upon t into integration over the period t z of t into e raised to minus jk omega 0 t into dt. This is according to the definition. But here z of t is nothing but x of t convolved with y of t. So let us substitute the value. So 1 by t over the period t, x of t convolved with y of t into e raised to minus jk omega 0 t into dt. But according to the definition of convolution, now we'll put the value of this entire term. So we have x of t convolved with y of t is equal to integration over the period tau x of tau into y of t minus tau into d tau. So this is according to the definition of convolution. So now we'll put this value in the above equation. We'll put this value in above equation. So now we'll get z of k is equal to this 1 by t will be as it is integration over the period t, and now in bracket I am going to put the value of xt convolved with yt, but that value is again integration over the period tau x of tau into y of t minus tau into d tau into e raised to minus jk omega 0 t into dt. So after substituting we'll get this. Now we'll simply change the interchange the order of integration. So we will get z of k is equal to 1 by t over the period t. Let's take this x of tau outside. Integration over the period tau y of t minus tau into e raised to minus jk omega 0 t into d tau into dt. Now we'll substitute this t minus tau is equal to m. So put t minus tau is equal to m. Therefore t is equal to m plus tau and dt is equal to dm. Now we'll put all these in the above equation. So we'll get z of k is 1 upon t integration over the period t x of tau into integration over the period tau y of t minus tau means it is m into e raised to minus jk omega 0, but the value of t is now m plus tau into dm into d tau, because now dt is equal to dm. So for this dt we have written dm and d tau will be as it is. So now we have z of k is equal to, now we'll first make this term separate. So 1 by t integration over the period t x of tau integration over the period tau y of m into e raised to minus jk omega 0 m into e raised to minus jk omega 0 tau into dm into d tau. Now we'll rearrange the terms. So we'll get 1 by t into integration over the period t x of tau into, now we'll take this term e raised to minus jk omega 0 tau into d tau and integration over the period tau y of m into e raised to minus jk omega 0 m into dm. Now we'll substitute the value for this terms in the bracket. So this value, that is integration of x of tau into e raised to minus jk omega 0 t, according to this definition, will give you t into the Fourier coefficient. So we'll give t into x of k into, for second term we'll get t into y of k. So which is equal to z of k, 1 t gets cancelled, so t into x of k into y of k. So this is what is the required proof for the convolution theorem or convolution property of the Fourier series. So keep watching my channel, and if you like, then don't forget to share and subscribe to my channel. Thank you guys. Thank you so much.